Today's lesson's on pages 272 and 273, Unit 10, Lesson 4, Creating Equations of Polynomials. You want to have your graphing calculator and a highlighter. So the connection between zeros of a polynomial and its factors should now be clear. Right? If we have a 0 of 7, then one of its factors is x minus 7. If we have a 0 negative 5, then a factor is x plus 5. This connection can be used to create equations of polynomials. The key is using the factored form of the polynomial. So the factored form of a polynomial, if the set r sub 1, r sub 2, r sub 3, etc. represent the roots or zeros of a polynomial, then the polynomial can be written as y equals a times x minus r sub 1 times x minus r sub 2, and so on, where a is some constant determined by another point. Our first exercise, determine the equation of a quadratic function whose roots are negative 3 and 4, and which passes through the point 2, negative 5. So we begin with our shell, y equals a times x minus the first root times x minus the second root. The point is xy, is x value 2, y value negative 5. We first substitute the roots and then substitute the point. So first substitute root, and then substitute point. Our roots are negative 3 and 4. Y equals a times x minus negative 3 times x minus 4. Just clean that up. Y equals a times x plus 3 times x minus 4. So we have the root substituted in. Now we want to substitute the point in. Substitute for the point and solve for a. Negative 50 in for y, and 2 in for x. That's 5 times negative 2 is negative 10. So divide both sides by negative 10 and a equals 5. Express your answer in standard y equals ax squared plus bx plus c form. Alright, so we have our a value of 5. Now I'll go back up to this piece right here and replace a with 5. Y equals 5 times x plus 3 times x minus 4. It asks for standard form, so we do have to multiply this out. I'm going to multiply the two binomials, getting x squared minus 4x and plus 3x is positive minus 1x and minus 12. And then, so that's the trinomial that results, and then distribute 5 over parentheses. We have y equals 5x squared minus 5x minus 60. Right, so that right there is telling us that our y-intercept should be negative 60. So it should cross the y-axis about here. Let's change the color here. Okay, so this is our answer in standard form. This is it in factored form. Right? Sketching a graph, I know that root is negative 3 and positive 4. 1, 2, 3, 4. It's quadratic. The leading coefficient is positive, so it's going to rise right. And we throw it into the calculator. We'll have to adjust our window to go from negative 100 to positive 100 for our y's. I'm just going to keep the x as is. In y2, I'll just put the factored form. Oh, you know what? I don't need to do that. What we want to do is check the table for the point, right? As a check. Look at table. So second graph is the point on 2, negative 50 there. Yes, it is 2, negative 50. We know we have the correct equation. It's important to understand how the a value affects the graph of the polynomial. So we're going to explore, consider the quadratic polynomials of the form y equals a times x plus 2 times x minus 5. What are the x-intercepts of this parabola? Okay, well, if those are the factors, then our x-intercepts would be negative 2 and positive 5. Sketch on the axis given the following equation. Alright, so I'm going to color code these. So in blue, the first one, x plus 2 and x minus 5. And let me change our window to match this here. So we got something that's a little similar to this. Red and then green. We know it's like this 2, it's like the transformation, a dilation of 2 to the y. So we recall from last unit, what's happening is it's like stretching. It's red, and then the last one. This is in green. It stretches even further. As we can see from the exercise, the value of a does not change. The zeros of the function, they remain the same, but it vertically stretches the function. So we can create equations of higher powered polynomials in a similar fashion. Create the equation of a cubic in standard form that has x-intercepts negative 4, 2, and 5 and passes through the point 620. Verify your answer by sketching the cubic's graph on the axis below. So our x-intercepts are -4, +2, and +5. We start with our shell, y equals a times x minus the first root times x minus the second root times x minus the third root. In other words, y equals a times x minus -4 is going to be x plus 4, x minus 2 times x minus 5. Right? Again, as we said before, if 5 is a 0 or a root, then x minus 5 is a factor. If 2 is a root, x minus 2 is a factor, and if -4 is a root, x plus 4 is a factor. Now, we're going to replace our x's and, let's see, our xy here, replace that. So our x's we replace with 6 and y with 20. That's 10 times 4 is 40 times 1, that's just that, 40. So 40a, divide both sides by 40, and a equals 1/2. Again, it says standard form. You know what? I'm going to cross off. We don't need standard form. We'll leave it in factored form. Y equals, a is a half, so 1/2 times x plus 4 times x minus 2 times x minus 5. Let's put that into the calculator. Simply easier to type in 0.5 instead of a half. Change the window, -7 to +7. -100 to 100. Check the table of values for the point 620. So the second graph. Yep. And point 620 does lie on the graph. So that's verifying that this is correct. Exercise 4, create the equation of a cubic function. Again, please, let's cross off standard form. We will leave it in factored form. That has a double 0 at -2. That means at -2 here, it bounces off. So if it's a double 0 at -2, and x plus 2 is a factor 2 times. And another 0 at 4. It also has a y-intercept of 16. This y-intercept of 16, that means an x value of 0, a y value of 16. Starting with our shell, y equals a times its cubic, x minus the first root times x minus the second root times x minus the third root. minus the negative 2 is x plus 2, and x minus 4. Now, substitute 0 in for x and 16 in for y and solve for a. Two times 2 times is 4 times negative 4 is negative 16. 16 equals negative 16a. Divide by negative 16 and a equals negative 1. In factor form, y equals negative x plus 2 times x plus 2 times x minus 4. Since it's negative, it's going to fall, right? So let's see. Negative x plus 2. There it is, tangent to the x-axis at an x value of negative 2. Let's check our table of values. Is the point 0, 16 the y-intercept? Yes, it is, 0, 16. Here's our equation. Make sure you have an equation and equals y. How would you describe this graph at its double root? At the double root, x equals negative 2. The graph is tangent to the x-axis. Bounces off the x-axis. I thank you for your attention.